Although it's a few years old, my ROS2 build series is still a great introduction, except for one big problem. It uses Gazebo Classic, which doesn't run on newer versions of Linux and ROS. The good news is it's pretty easy to swap over to the new Gazebo, and I'm going to talk you through that process. I'm going to do a quick rundown of how we got here. We're going to look at the main differences in how the new version is structured, and then exactly what changes you need to make. This video is good for people who are about to start the tutorials, so you know what's going to be different, or for people who are upgrading their own project. I'm going to be using ROS2 Jazzy and Gazebo Harmonic, but it should be pretty similar for other combinations. Back when I first started making my tutorials, Gazebo 11, as it was known, was still the main simulator for ROS. There was a new version that was going to replace it called Ignition, but it was a bit rough around the edges, and in particular ROS2 control didn't fully work in it, so I decided to stick with the old one. Fast forward a few years though, Gazebo 11 is now Gazebo Classic and doesn't run, and Ignition is now called Gazebo and works just fine. Probably the biggest thing to understand is how the way we get information in and out of Gazebo has changed. In both versions, Gazebo has two parts, a server and a client or GUI, that we usually run together and they can talk to each other. Both versions have plugins that can extend the functionality of the server or the GUI. Both versions have the concept of sensors that are attached to the robot. But here's where things get a bit different. In Gazebo Classic, to get a sensor to function, like simulating a LiDAR scan, we would find a relevant plugin and we attach the plugin to the sensor and it handles all the talking to ROS. If you have a camera sensor, then you do the same and that plugin will do what it needs to do and so on. In the new version, we have similar plugins, but instead of explicitly attaching them to each sensor, we just load them all at once in a bundle. And rather than talking to ROS, these plugins will publish the sensor data to a topic inside Gazebo. Gazebo topics are their own little world, completely separate to ROS topics. To get the data out to ROS, we just run a single instance of a program called ROS GZ Bridge. We tell it which Gazebo topics to copy over to ROS and which ROS topics to copy over to Gazebo. Some external plugins like ROS2 Control work just like they used to. In this case, it would bypass all the Gazebo topics and all the ROS topics so that it can talk directly to the ROS2 controllers with minimal overhead. So how do we upgrade? Here I've got a system running Ubuntu 24.04 Noble and ROS2 Jazzy. Now I'm going to skip over all the core upgrading to Jazzy stuff, that'll be in a different video. This is just about the new Gazebo and should be pretty similar across other versions. I'll start by installing Gazebo with sudo apt install ROS Jazzy ROS GZ. And now I'm going to make a new workspace, clone my Articubot1 repo, and check out the Humble branch. I'll commit everything I do in this video to Git under the branch new Gazebo and include a link down in the description so that you can take a closer look at the code differences for yourself. So I've checked out the Humble branch, and as I said, I'll do a different video covering the general upgrade to Jazzy, but this will work just fine for now. Let me just get up into top level, and I should be able to build it with Colcon just fine. But if I try to source it and then launch my normal sim, it doesn't work. No surprises there. The good news is that the Gazebo team have actually written a really handy migration guide, and they're using the Turtlebot 3 package as an example, but it's very similar to my Articubot 1 package. So I'll be pretty much just covering the same things that are in that. I'll include a link in the description. I've also got one that I prepared earlier. We'll be using that as a reference. So I'm going to start by opening a new VS Code window, and we'll open our new workspace. And if we look at this error, our first target is going to be this Gazebo ROS package in the launch sim.launch.py. So if we find Gazebo ROS, we can see it's referenced in a few spots, and the new equivalent of that package is ROS GZ sim. We can actually just do a find and replace for that one. So you can see it's just going to change these 4 instances. The launch arguments here have changed too. Instead of extra Gazebo args, it's just GZ args. And the arguments that we're going to pass in, we're going to get rid of this. We're actually going to make this an array. We need -r to tell it to run the simulation as soon as it starts. And then we need to supply the path to the world file. Previously, the world got passed down transitively as a launch argument, but it doesn't happen anymore. We need to do it ourselves. Now, we could just hard code the path directly into here, but I'm instead going to set it up as a launch argument to this launch file. That's not really the topic of this video, so I'm going to skim over it pretty quick, but you can slow down and look at it closely if you need to. We can also delete that Gazebo params file. We don't need that anymore. And in fact, we can delete the entire file here. I'll just make this a bit bigger. Now the migration guide suggests a few other arguments to add here. They add -v4, which tells it to print more things to the terminal, more information, which is very useful when debugging Gazebo. They also have some other parameters to run the server and the GUI separately, but we're going to do it all together. Make sure you have this space here between whatever the last argument here is and world, because that's all going to get concatenated together into one string. Now, the other thing we need to add here is on exit shutdown. Set that to true. And that tells it when Gazebo closes to shut down everything else. Next up is the spawner. If we have a look at my diff over here, you can see, again, we've changed that package name. The spawn entity.py has become create. The entity parameter has become name. And then I've also told it to spawn the robot a little bit above the ground because I was having some trouble with it falling through the ground. So I'm just going to make these changes in the new version. This is a good start. But if we try and launch Gazebo again, oh, I wasn't expecting this one. I don't have a few of the other dependencies installed. I'm going to go install them now in the background. All right, we'll try that again. Oh, and I was meant to rename this launch file from Gazebo to gz_sim.launch.py. So let's try that again. Finally, it's trying to launch Gazebo, and it crashes straight away. If we have a look through, we'll find it's trying to load a whole bunch of things that don't exist. First up, we're going to modify the exacro for our sensors to include the new plugins. So if we go back to my one I've prepared earlier and look at the LiDAR, you can see we change the type from ray to GPU LiDAR. We change this ray tag to LiDAR. And then we get rid of this whole plugin section. We get rid of the ROS topic stuff. All we do is setting the topic name to scan and the frame ID to laser_frame. So I'm going to go make these changes. All right, that was pretty quick. Now let's do the camera. So similarly, we look at the camera exacro. We can see we add this camera info topic. And again, we're getting rid of this plugin line here, setting the optical frame ID, and we also specify the camera image topic. And that should be our camera done. For both of these, we need to tell it to load the sensors plugin, which isn't on by default, I guess because some people have robots without sensors. To do this, we need to make a custom world if we haven't already, and I'm going to start by copying their empty world. Now, I actually can't remember where I found this empty world, so here is my old one. I'm going to delete all that and paste the contents of my new one. So I found this somewhere, And you can see it loads the physics plugin, it loads the sensors plugin. The reason it has to load physics and all that, they'll be loaded by default, but if you're specifying any other custom plugins, you also have to specify these ones. Then we've got a sun and a ground plane, and then some other stuff that I can delete. So I'm going to save that as my new empty world. So let's see if we can launch now. Now we can drag and drop some boxes in here. You might think that the LiDAR is not working, but actually we've got to open up this visualize LiDAR panel. So we can tick display LiDAR. Oop, hit refresh to get that scan topic. So there we go, that's what the LiDAR is seeing. And this gives us a bit of control over what it looks like. We can visualize them as rays or points or whatever we want. We can also choose to only show the rays that are hitting objects. And you know how I said before that these are getting published to topics inside Gazebo? We can actually type topic here. So topic viewer, scroll down. These are all the topics we've got published, and we can open up scan. So we can see that's the content that's going to be in this scan topic. To see this data in RViz, we need to bridge the topics over to ROS. I'll create a new YAML file in our config directory and call it gz_bridge.yaml. And for each topic, we're going to need to tell it the ROS topic name, the Gazebo topic name, the ROS topic type, the Gazebo topic type, and which direction the data is going. Is it ROS to Gazebo or Gazebo to ROS? So as an example, our first one is going to be the clock. So this is the simulated clock time that ROS needs to stay in sync with the Gazebo. So the ROS topic name clock, Gazebo topic name clock. The ROS type is ROS graph messages clock. The Gazebo type is Gazebo messages clock, and it's going from Gazebo to ROS. I'll also add one for the scan topic and the camera info topic. The camera image data will do a little bit differently. So now with this YAML file, we need to run the ROS GZ bridge and pass these in as parameters. So we'll go back to our launch sim. And if we go up, we can see here where I load the twist mux parameters. I'm going to come down here below our spawners and create one called bridge params. And of course, that's going to be gz bridge.yaml. And then similar to loading the twist mux node or any other node, we're going to launch the ROS GZ bridge package. The executable here is called parameter bridge. We're going to pass in our bridge params. We don't have to worry about remappings. And of course, this is our ROS GZ bridge node. For our image data, we run another bridge node. This is a special one. So we'll go ROS GZ image bridge. And for this one, we have arguments. And we're just going to put in quotes. Whoa. Let's not open the terminal. Put in quotes /camera/image raw. Whoops, I went a bit off script there and made a few mistakes. Firstly, I missed the D in bridge. Secondly, unlike the twist example I copied, the bridge params file is not a ROS params YAML file, so we can't pass it straight into the parameters argument like this. Instead, there's a regular parameter called config file, which is the path to our bridge params YAML. Thirdly, I forgot to change the package and executable names for the image one. You can see the correct values here. And fourthly, I forgot to rebuild with Colcon, so the new bridge params file didn't get copied over. And make sure we add these down to the bottom of our launch. Now, if we kill everything that was kind of half dead before and relaunch it, I'm not sure why it's not working, but we're just going to move on ahead and get ROS2 control going. So if I start my controller, you can see this isn't working. I can't drive my robot yet. So we'll go to our ROS2 control Xacro. And anywhere that had Gazebo ROS2 control, so this is in 3 spots, these all are going to become GZ ROS2 control. Help if I do that right. This Gazebo system becomes Gazebo Sim system. Now this plugin needs to get qualified, so it becomes GZ ROS2 control Gazebo Sim ROS2 control plugin, and the file name, we add this little suffix dash system. There's one other thing we've got to do on Jazzy at least, and this isn't a Gazebo thing, it's a ROS2 control thing. They've deprecated the unstamped twist that I was using for the diff drive controller in this repo. So in my controller params, I'm going to comment out use stamped vel, and then in my joystick launch file, I'm going to uncomment twist stamper. So that'll be generating stamped twist messages for me to use. And I'll go through that in more detail in the Jazzy specific video. Now, I think the reason that the GZ bridge wasn't working before was probably because I need to rebuild with Colcon in order to add the new file that I've added. So we rebuild, and I'm hoping now if we rerun that I'll be able to drive my robot around. No, no such luck. All right, 2 little problems there. One, I need to install ROS Jazzy GZ ROS2 control. And the other is that back in our launch sim here, I forgot to change this one to be called image bridge, the one that's running our image one. And this is in a package called ROS GZ image. So we'll try again. Fingers crossed. All right, it looks like we're getting ROS2 control errors here. And I'm suspicious something might be running twice in the background. So I'll just try and clean that up. So there are other ways I could have done this, but let's see if that will let us launch correctly. Hopefully now we can put our cubes in. There we go. Let's make those a bit smaller so we can see our laser data showing up in RViz. Now, I assume we're still not driving around. Whoop, there we go. Great. We've got driving too. So that should all be working. I can add a camera. We can see there's our data. I can add a robot model. There's our robot moving around in Gazebo and showing up in RViz. This is basically done now, but I'm also going to go back and fix the non-ROS2 control diff drive mode that we had as an option. In case you're using that, I'm going to really quickly rush through that. I'm basically doing the same things that are done in that migration guide. So here's the Gazebo control Xacro file, and you can see here is the old version on the left. So the plugin names changed, wheel diameter became radius, instead of wheel acceleration we have linear acceleration, we specify a topic, some of these names changed, so on and so forth. The other thing that I didn't have in the original was the joint state publisher plugin, which I think I would have needed. I would have thought I'd notice if I wasn't getting joint states, but maybe it was just never working. So if we take all of this and copy that into our Gazebo control file, and then we're also going to need to go and add a whole bunch of extra topics to our bridge, because this plugin does use the Gazebo topics. It's not bypassing everything. So we've got ODOM, TF, the command velocity, and the joint states. So if I go to my launch sim.launch.py and change ROS2 control to false, I should be able to close, whoop, I don't want to close RViz, close Gazebo. Relaunch it. And we're still driving around. Let's put some cubes in. Now RViz will be frozen. We just have to hit reset to get the new clock. Sure enough, there we are. We're working now with the Gazebo diff drive plugin. And we've even got our joint states working. And if you're trying to troubleshoot anything, remember the Gazebo topics live in their own little world. One useful thing, if we type topic echo, for instance, we can echo the command velocity that's being passed in. So it actually is coming off the bottom of the screen, but if we pop out this window, you can see if we resize this, it kind of just hovers over the top, but we can see the data coming through, passing those command velocities. Now, the last thing to do is our world is looking a bit boring. Now, I was going to show you how to add new models and stuff into the world, but it turns out that actually doesn't quite work properly on this version. It has a bunch of issues. I'm going to show you how to work around them, but there's enough in there that I'm going to save that for another video. So all I'm going to show you at the moment is how to save a very basic world. So say we've made a world with this. We can click on our cylinder here. We can drill down into the visual. We can change the diffuse color, so we can make it orange. Now, if we want to save this world, we can delete our robot. So we right click there and go remove, save world as, and then I'm going to go and find my old obstacle world. Now, it wants to save it with the extension SDF. So we type a file name in here, click save. Do you want to replace it? Yes. Then it doesn't actually replace it, and then you get to this page and it won't let you click OK unless this ends in SDF. So we can change that to SDF, and now we have obstacles.sdf. So we can delete our old obstacles.world and rename that if we want. So now, if we close Gazebo, if we relaunch it as is, we should be getting our empty world. However, if we pass in world source TikiBot1 worlds obstacles.world, then hopefully we will get our new custom world, apparently without the colored cylinder. I probably just did something wrong there. As I said, I'm going to do a whole other video on how to set up worlds in the new Gazebo. I hope that video is helpful for some of you in figuring out how to upgrade your old project from Gazebo Classic to the new Gazebo, or for those of you who are about to kick off on my tutorials in knowing some of the things you're going to have to change as you go through it. As always, down in the description there'll be a link to the discussion thread for this video where you can ask questions and help each other. Thanks to the patrons who support this channel, especially Anonymous. If you want to contribute financially to this channel, then head over to the link down in the description and you can do that there. You'll also get access to our Discord server. I've got a few other videos coming up, including how to do the robot tutorials in Jazzy, how to do the worlds in Gazebo, as I said, and a few other things. So make sure you subscribe so you don't miss out on them. All right, I'll see you next time.